Okay, so we'll take another problem. This is actually the DP problem, but this is actually quite a level up problem from the last we have done. We have done climbing stairs problem. That was the basic DP problem that we have done. Like it was climbing stairs. That was the introduction, and it was the easy problem. Now we'll take one level up, right? So this is now we'll take the house robber problem. This is also a easy problem, but it's a level up from the above problem. Again, like I will go with the recursive approach, then top down approach, then bottom up approach, how to put the dynamic programming, all those things. So you will find like on Leet code, it's problem number 198. That is the medium there. So the problem is about like you are a robber and there are houses like, and each houses has a number like maybe some amount, right? A1, A2, A3, right? Now you need to rob maybe A0. You need to rob these houses to get the maximum profit. Or maximum amount, right? The only constant is like if you have robbed A0, you can't rob A1. Like you can't rob the adjacent one. If you rob A1, you can't rob A2, but you can rob A3. Similarly, if you have robbed A0, you can't rob the adjacent to it, that is A1, but you can rob the A2, right? Suppose there is A4 here. So you can, if you have robbed A0, you can rob A1, you can rob A2, you can rob A3 as well. Just adjacent you can't rob. So suppose it has 5, it has 6, it has 9, it has 2, it has 1. So you need to maximize this amount. So once you rob this one, right, maybe what would be the maximum? You can't choose 6. So 5 plus 9, that is 13, that is 14. If you have chosen 9, then you can choose 1, right? That is 15. This is your amount. If you rob, let's suppose 6, but you can't rob 9, you will go to 2. So 6 plus 2, 8, right? If you have robbed, let's suppose, starting from 6. So basically what at every point, whenever you are standing, here the 15 is maximum actually. So at every point you have two choices. One is either you can rob this. If you rob this, then you can skip this and pick the maximum from this, right? If you are not robbed this, then you can pick the maximum of remaining. So it's a recursive problem, like because it's basically you need to find maximum. Maximum and minimum generally the trade-off. Whenever you heard in a question maximum or minimum, generally a trade-off. And if you have choices, right? You have choices. So by choices, you can make a recurrence relation. So if there is a recurrence relation, and then you have to get the maximum or minimum, means it's a recursive problem that we actually understood in the last lecture. So I will explain you one more thing. A1, A2, A3, A4. These are the 4 options. While you are on A1, you have two choices. Like at last you need to maximize the amount, right? So you have two choices. Either you can include current or you can exclude current. We have two choices. if you include current, if you, like, we have two choices. If you follow the first one, if you include the current, then you can't choose the adjacent to it. This is A2. So include current and then maximum of A3. From A3 you can choose the maximum, like whatever the maximum, right? If you don't include A2, then whatever is the maximum, whatever is the result till from A2, you will get it. These are the two things, right? So I will explain you with one of the example as well. So let's suppose you have so in the input, actually the number array will be given. Like the language is a little bit complicated, but in the question you will get a num array. So here let's have 1, 2, 3 and 1. From this you need to get the result maximum. So actually if you choose 1, right, you can choose 3. 1 plus 3, that is 4. If you choose 2, then you have 2 plus 1, that is 3. So maximum is 4, so your answer is 4. Another example, you have 2, 7. These are the lead code example. You will get internal lead code. Right. So if you choose house number 1, right, you have two choices here, whether to choose this or not. If you choose house number 1, then you can choose 7, you can choose 9. If you choose 9, you can choose 3, you can choose 1. So here it is 12. If you haven't choose house number 1, then you have chosen maybe 7. That is the choice 1. This is choice 1, this is choice 2. If you're chosen 7, you can't choose either 2 or 9, right? These are the adjacent. Then you need to choose either 3 or 1. So 3 is maximum, right? So you'll choose 3. So it's 10. So answer is 12. Or maybe if it is 10 here, right, and you chooses 2 here, let's suppose it's 10 here, you chooses 10. Now 7 you can't choose, you have chosen 9. Now if 9 you have chosen, you will choose 10, that is 1. But if you have chosen 7, 2 haven't you chose 7, right? And 9 you can't choose. But from 3 and 10 you have the option, right? Because like 3 is not adjacent to 7, 10 is not adjacent to 7. So from 3 and 10 you have an option what to choose. The maximum is 10, so we'll choose 10. Right? So that's how it will work. So what are the conditions like we have seen here? You have actually two choices. Right? First, rob current house. Fine. And second, don't rob current house. You have these two choices, right? If you have chosen option 1, then actually you can't rob the second, right? If I give you this I, if you choose an I, right, these are the I. Either you can choose I or you can't choose I, like the position, I is the position. So if you choose an I, you can choose I minus 1, right? The adjacent to it, right? But you can safely choose I minus 2, right? Whatever the max till I minus 2, you can choose this, right? If you choose a second option, like if you don't choose an I, then whatever is the maximum from I minus 1, that you can choose. These are the two things. So what is our recurrence relation? So that is actually if you see the recurrence relation, that is actually the robbery of the current house if you have chosen first one, like you are seeing here, right? If you chosen first one, robbery of the current house, then you can choose from I minus 2. So if you're choosing current one, so you will have this robbery from previous houses, like previous to previous, right? Because adjacent you can't choose. So first choice is this. If you choose current option or option, then apart from adjacent, you can choose the robbery of to previous. Second, if you haven't choose the current, then you can have the robbery from previous, whichever is max, right? So a recurrence relation become like, if you see robbery is a function, robbery of I will become so first choice is if you have chosen current house, then you have current house plus robbery of previous to previous, right? Previous is, for current one is I, previous is -1, and previous to previous is I -2. So this is one, current house plus robbery of -2. Second is if you haven't chosen the current house, then robbery of previous house means I -1. So whatever is max from that will be answer of I. So you will put a max function here, right? Whatever is the max between these two, this one and this one, that will be your robbery of I. So this is the recurrence relation. With this recurrence relation, we can write a recursive code. The base condition is fine, right? The base condition is normal. If you are whatever the number is, whatever the I, it is less than 0, then you can actually return 0. This is the base condition. And recurrence relation will be max of robbery of I -2 plus current, comma, robbery of I -1. Yeah, fine. So this is the recurrence relation or recursive code. So in the next lecture, I will code this into the Leet code, and then we'll see what is the problem into this solution, this particular solution, and then we can jump to the memorization and whatever it is needed.